In this question, a student tries to determine the latent heat of vaporization using the electrical method. So at a power of 30 watts, the liquid is vaporized at a certain rate. Power of 60 watts, the liquid is vaporized at another rate. So naturally, right, the higher power leads to more liquid being vaporized per unit time. So now, right, how do we go about finding out the latent heat of vaporization of this liquid? In the ideal scenario, right, the heat supplied by the heater will be equal to heat absorbed by the liquid. Okay. However, right, in the real world, there's actually heat loss to surrounding as well. So P equals to latent heat times dm dt, right, which is the rate of vaporization, has to include a new term which is a small h. So that is rate of heat loss to surrounding. So this term is actually unknown, okay? And that is actually the reason why we do this experiment over two different power. So we can form two equations for the 30 watt case and the 60 watt case. We are assuming, right, that at the boiling point where this experiment is taking place over, the rate of heat loss to surrounding for both 30 watt and 60 watt should be the same. Why? Because rate of heat loss, right, depends on the object's temperature and the surrounding temperature. So the container of the liquid is at boiling point in both cases. Surrounding is the same room temperature in both cases as well. So we expect both cases, right, the system to be losing heat at the same rate. So that's why, right, we can write out these two equations and have the H being the same. And once you do that, right, you can solve them simultaneously, subtract one from the other, and find out the LV. The other wrong answers in this question, right, correspond to the scenario whereby you did not account for the effect of H. You simply use P equals to LV times the rate of vaporization of the liquid, okay, with either the 30 watt numbers or with the 60 watt numbers. And one final answer, right, which is also wrong, is taking these two answers and averaging them, okay. So all are not correct.